Hey, what's going on, guys? My name is Dave here with Go Gamers, and today we got this PS5 in that is not booting up at all. What it does is the customer explains it as it turns on for a couple seconds, blinks blue, and then turns straight off. So let's try to get into this and try to figure this out. Also, I want to let the people who know who's been returned to my channel every day, our gogamers.com/repair form is back up. So if you are wanting to ship in your game console like how this customer did, go to gogamers.com/repair, fill out the repair form, and then you can be able to ship it directly into us. But besides that, let's see exactly what's going on with this PS5. All right, guys, so we have the Ghostface Killer PS5, and we're going to hook this thing up, see exactly what's going on. Customer says she went and blew it out one day, and now it just doesn't turn on. Oh, there it is. So it stays on for a little bit. I'm going to try to turn it back on. See, we get the blue light. Bam. Like, that wasn't even a second that next time. So now what we need to be able to do is actually be able to get this thing, take it apart, and see what's going on. So I'm going to boost pass through the disassembly process when it comes to this. So I'm just going to take this apart on a repair bench, see what's going on. So we're going to get down to the motherboard and see exactly what's happening with this thing. Now, I'll be honest, typically with these PS5s, usually when I see when someone gets inside of it and try to clean it or anything like this, anything like that, I want to say maybe 9 times out of 10, when they're usually spraying stuff around, they're usually disrupting the liquid metal, and that liquid metal usually pops out of place. It flies somewhere on the motherboard, shorting out or grounding out something that it's not supposed to ground out. Now, I'll be honest, man. These PS5s with the liquid metal, the liquid metal is absolutely terrible. I know there's some people out there that will tell you laying it down or standing it up doesn't make a difference. I'm going to be honest. And I actually made a video experimenting on this. I'm probably going to release it here soon, where I 100% undoubtedly proved that it does make a difference. I mean, I've repaired thousands of PS5 so far, and this liquid metal does freely flow inside of these game consoles. But I don't know 100% what's going on until we get inside of there. So let's get all these screws out, get it down to the board, and see what's happening. All right, guys, so we have it down to the motherboard right here. I do have, if you can see down here, these are my alligator clips that hooks up to my power supply. So as you can see right here, I can't visibly see any liquid metal on the motherboard, but we can see a lot of liquid metal right here, which is very common. We can see it's even spread onto the pad because obviously she more than likely stands her console up vertically. But just because we don't see liquid metal on the motherboard doesn't mean that there isn't any liquid metal on this motherboard. But what I'm going to do is I'm going to go over here to my power supply, and we are going to turn it on. So I'm just going to turn it on to see how many milliamps I'm drawing. Okay, so it gets up to about 300 milliamps, go down to about 10 milliamps, bounces around between 9 and 10 milliamps. So that is obviously not a normal boot sequence. So what I'm going to do in these type of situations, where if you can't see if there's any liquid metal on the motherboard, what I do is I take a toothbrush. Let me remove these alligator clips. Take some 99% IPA, dip the toothbrush in there. This is the easiest way to find out. We're going to go back over to the upper cam, and we're just going to scrub around. scrub around on all these components over here and just get this all clean. Another thing I do too is take my syringe with my 99% IPA. This is nothing but just a bottle with 99% IPA in it. I'm taking it and I'm going around. I have a towel in my lap that I use to clean up a lot of the excess off of it. And we're just going to continuously clean it up. Now, obviously, if we still don't get a normal boot sequence after this, then there's obviously something else wrong, something else deeper that we got to figure out. So let's go ahead, finish getting this motherboard cleaned up. We're just going to take our time, go around. I'm going to take my towel, and then we're going to go in and see what kind of boot sequence we get after this. All right, so I just tried it again. We are still receiving an abnormal boot sequence. So what I'm going to do is I'm going to take my multimeter and I am going to go on ahead and go around and just start testing fuses and caps that are highly known to blow on these consoles and see what else could be going wrong. So let's start doing some testing and try to figure out where this short is coming from. Alright guys, so we have my UART tool hooked up to the computer and we're going to be able to fully diagnose this thing now. If you guys don't know too much about the UART tools, this is how you can be able to read the error codes that's coming from the South Bridge on PS5s. And these UART tools, they can use for various different things. These PS5s actually run off of 3.3 volts when you're doing that. So I got it hooked into the power. I don't need to power it on, but I do have it reading the codes off the South Bridge. So let's go over to my screen. So this right here is the UART tool that I use. It's called Console Servers Tool. Now with Console Servers Tool, this is a free one. There's another one where you could be able to pay for it. I would not recommend paying for it because this one right here works just as good. They do give out frequent updates and they do constantly update these codes that sends it straight to the program. Now in here, it'll tell you the pinout points. So if you are wanting to do this yourself, if you want to get a UART tool, you can get the UART tool. If you just go back a little bit in my video, you'll see what type of UART tool I'm using, but you can use really any UART tool. Go back, you can ground it here. You will put your RX here. So this is your TX line, but your RX goes here, your TX goes here, and it even has the other revisions of the PS5 motherboard. So let's go over here. We're under UART. I'm going to click on USB serial because that is what I have currently plugged into the computer, and I'm going to click on run. And now what it's going to do is going to run every single error code that has ever been processed through the PS5. And it didn't. So let's figure out what's going on and why it's not running it. Okay, so here is our severe. This is the main one that we should pay attention to. As you can see, it tells you what levels will prevent it from not turning on. Severe. High means console may turn on, may freeze. Medium, everything appears fives. And low just means nothing to concern about. So lows, we're not going to concern ourselves with these couple ones right here. We're going to concern ourselves with the top one right here, the severe one that's preventing the actual console to turn on. So this is APU, VRAM, 2 phases, power fail, and it tells us exactly what to check. This is why I like this, because it pinpoints it down exactly where to be able to look out for, and even gives us the milliamp draw on how much it typically draws in when it shows this error code. It says it's a single beat, 1 second blue light of death, which is exactly what we're getting right here, right now. So what I'm going to do is I'm going to go ahead, desolder that real quick, go back over to the APU, see if there was something that I missed, something that I didn't see when I was testing everything out, and then try to pinpoint where this short is coming from on this PS5. All right, so here we are. Looking down at our PWM chip. I'll change the lighting a little bit so you can see what the chip look like. There we are. So let's go ahead and see if we are currently receiving any shorts. So I have my black pole ground. We're going to touch to see if we have any shorts coming out of these caps on this board. So far, no shorts. Okay, so I'm not receiving any shorts from the PWM chip. Let's go over and let's check out these MOSFETs right here. And all we have to do is just put our probe over here. See, we get ground over here. This is supposed to get ground. Put our probe over here, and we are not receiving a short. So that is good. Now let's go over to our next set of MOSFETs that I showed you guys. Is way down below. So black probe is on ground, and I'm gonna put, see, this MOSFET right here connects to this set, and this MOSFET connects to this set. So let's test out this set. So we're getting ground over here, no short. So far so good, no shorts or anything. Over here, we're not supposed to get ground right here. We're getting ground, meaning that there is a short coming from over there. And I'm getting a ground from all these caps. There should be no ground coming from over here. So that tells me that something is going on, more than likely with this MOSFET. It's kind of scratched up too. But what I'm going to do first is I'm actually going to start off first. Let me turn off this multimeter. Keep on beeping at me to change the batteries. I'm going to start off cleaning that side just to make sure no liquid metal is on it. And that doesn't do the trick. Then we're just going to go ahead and start the process of elimination. We're obviously going to start off with the MOSFET. Take off the MOSFET, then just take off things piece by piece and see exactly where this short is coming from. If I take off the MOSFET, if I don't immediately see a short, then what I'll do is I'll take my my power supply. I'll probably just pump 1.2 volts into it and see if I could be able to pinpoint the short with my thermal camera, but hopefully it doesn't come to that. Hopefully this is just as easy as lifting off this MOSFET, and that's it. All right, so I have my 2R heat wand set at 500. I have my speed set at 4.5. And let's heat up this MOSFET, get it lifted off the board, and try to pinpoint this short. All right, so we have that MOSFET lifted off the board. I'm going to put my black pole ground. Still getting a short, but I'm going to clean up this area, allow it some time to be able to cool down, because what I've experienced a lot of times is when it's still hot, you'll still receive a short. So I'm just going to give it a little bit of time to cool down and get a lot of this excess solder up. All right, so I did a little bit of cleaning. Let's go ahead and test it out, and we're still receiving a short. All right, guys, so I just decided to do the process of elimination. So let's go ahead, and I'm just going to start pulling every single cap, including the ones under the motherboard, until we can be able to pinpoint exactly where it's at. Thermal camera couldn't see anything, and I'm not trying to be stuck working on this console all day, so let's get this knocked out. I also did forget to mention that I did put that MOSFET back on there as well. So the MOSFET that we took off, what we thought was a problem, I did get that back on there. But let's keep on doing some more testing. I'm going to use my multimeter and start trying to pinpoint what's going on. No longer getting a short. I got black probe on ground. No longer getting a short. No short on this cap. This cap is good. This cap right here was the problem. this cap is bad. So we just figured it out. So wasn't the MOSFET at all. It was this one cap right here. So I'm gonna put the other two caps back on, pull another cap from another console, and that should be it. So let's go ahead and get that knocked out. All right, so got my black probe on ground. Let's see if we get anything. Let me put it in continuity mode first. And we are getting no shorts now. We are no longer getting any shorts on any of it. So should work now. Let's go ahead and just get this thing pushed partially back together. See what we could get. Okay, now let's try to see what we could get. Blue light. And it's actually pulsating this time. It is holding, which is something it did do last time. Let's plug in this HDMI cord and see if we can get anything on the screen and see if it goes to the white light. It's at the white light. We're good. We got it working. So yeah, that was all that because of one cap. Jeez. So let's allow it a little bit of time to fully kick on. Yep, everything is good now. As you can see, I'm gonna turn it off, hold the power button if I can. Okay. All right. And it turns off perfectly fine. So yeah, this was a fun one, but we went on ahead and got this one pretty much all fixed up and ready to go for this customer. So that was an interesting one. She claimed that when she sent it into us, she claimed that she blew it out and then it just stopped working shortly after. So that makes me wonder if it stopped working and she thought blowing it out would fix the issue, because there was absolutely no liquid metal, no noticeable liquid metal anywhere on the board, and we found out that it was actually a cap that was blown right next to the MOSFET. So that's it for this one. If you guys did enjoy this video, make sure you go ahead and like, comment, subscribe. Also, if you guys are interested in sending your repairs, make sure you go to gogamers.com/repair. You can ship it in to us. We'll get yours repaired for you as quickly as possible. But besides that, I hope to catch you guys on the flip side. See ya.